Now we'll see general characteristics of the physical equilibrium. So at equilibrium, the measurable properties of the system becomes constant. So measurable properties means it can be pressure, vapor pressures, it can be solubility of the solid. So these are the some example that we have already seen in the physical equilibrium. So this property of the system must become constant so that equilibrium will exist. So this is one important properties. So in dissolution of solid in liquid, the solubility of solid should be constant at a given temperature. Second, at equilibrium there is a dynamic balance between the two opposite process. So like how dynamic balance means rate they are asking. So rate of evaporation is equal to rate of condensation, that we have seen in during the evaporation of water. So there should be dynamic balance, means both the rates should be having a equal speed. Equal speed I am speaking, equal speed should be there. The equilibrium is attained only in a system. The equilibrium is attained only in a system which cannot gain matter from the surrounding. So from the surrounding, nothing should be added in the at the stage of equilibrium, or lose matter to the surrounding. So neither adding nor losing. The system is totally closed system. For example, if a evaporation of water it takes place in an open vessel. If you evaporate water in an open vessel, what will happen? No equilibrium is attained and whole of the water will evaporate. So this is not the stage of equilibrium. If you are taking under the closed equilibrium, you will get the proper equilibrium. Number 4, at equilibrium, the relative concentration of the two different phases. The concentration of the two different phases becomes constant at a given temperature. So let us take this carbon dioxide in gas form and carbon dioxide in aqueous form. So ratio of these two concentration, one is gaseous phase and one is the aqueous phase. Both should be constant at a constant temperature, and this constant is called is actually equilibrium constant. So there is a new term is coming, equilibrium constant. We will see this value in the coming topic. Again, this magnitude of the equilibrium constant represents the extent to which the process proceeds. So this will tell the extent of the reaction, what extent the reaction has been taken place, whether the reaction is completed, whether the reaction is very low. So this will tell the extent of reaction or extent of the process proceeds before the equilibrium is established. So if the value of equilibrium constant is high, if the value of this equilibrium constant is high, so what will happen? The greater conversion of reactant into product. So this is the indicator of the equilibrium constant. For the dissolution of carbon dioxide in water, so greater the value of this one, so greater is the extent of which CO2 dissolves in water. So these are the some characteristics of physical equilibrium. In chemical process. So under this heading, chemical reactions, we have two type of chemical reaction. One is the irreversible reaction, second is the reversible reaction. What is irreversible reaction? Reaction which can proceed only in one direction. This means if you take one reactant A, if you take second reactant B, so this reactant converts into product. So this is the one direction. But in reversible reaction, the reaction is going in both the direction. A is converted into product and product is also converting into the A. Means this reaction is symbolized by this sign of this equilibrium. So this is the sign of half arrow in either side. So this is the state of equilibrium. Now second, a product do not react under any conditions to give reactance. So whatever you will give condition, this will not go reverse back. But under this, products react with each other and can produce the reactant again under suitable condition. These two things are totally different. Now third, the reactant are completely converted into product. Here reactant is completely converted into product. But in this case, the reactions do not reach to completion. But reaction is not complete because product is converting into the reactant. So this reaction is the dynamic. Fourth point is that the free energy of this whole reaction is not equal to 0. It can be negative, it can be positive. So we will discuss this free energy in later stage of the topic. What is actually the free energy? Right now, just take this note that free energy of this irreversible reaction is not equal to 0. While in this case, free energy of this reversible reaction is always 0. So just take it. Now let us see some of the examples like barium chloride. When react with sodium sulfate, you will get barium sulfate plus NaCl, and this is the precipitate. So when precipitate formation takes place, the reaction cannot go backwards. There is another example of precipitation reactions, silver nitrate plus sodium chloride. So it will also forming the silver chloride precipitates. It also cannot go backward. So this is the problem in which the reaction cannot go backward. Decomposition reactions like thermal decompositions, when you take KClO3, it under the catalyst you will get KCl plus oxygen. Like ammonium nitrate, so you will get nitrogen plus water. This is also a irreversible reaction because we are getting gases. There are some neutralization reactions like a reaction of a strong acid and a strong base. This is the only case in which the reaction is irreversible. The rest of the neutralization reaction is reversible reaction. This is only reaction of strong acid and strong base is always the neutralization reaction. Redox and combustion reaction. So SnCl to FeCl3, it will give you SnCl for FeCl. This is a redox reaction. And burning of ethanol or combustion of ethanol is also giving CO2 plus water, or combustion of any hydrocarbon is example of combustion reaction. There are so many biochemical reactions like photosynthesis, like respiration. All these are also a irreversible reaction. Let us see some examples of reversible reactions. So under reversible reactions, like when iron is reacting with the water, it will give you Fe3O4 and plus hydrogen. So under the closed condition, this will give you a reversible reaction. Similarly, hydrogen iodide, it will give you hydrogen plus iodide. So this is also reversible reaction. There are some more thermal dissociation reactions which require heat. Calcium carbonate is giving calcium oxide plus carbon dioxide in a closed vessel. Similarly, PCl5, it will give you PCl3 plus Cl2. Acetic acid with ethanol under the acidic condition, it will give you ester plus water. So this is a esterification reaction. So this is esterification reaction also a reversible reaction in acidic condition. Ammonium hydrogen sulfides, it will give you ammonia plus H2S. Similarly, SO2 plus O2, nitrogen plus hydrogen, Haber's process, that is the formation of ammonia, is a reversible reaction. Some hydrolysis reactions like ester with alkali in presence of acid, it will give you same thing, that is a hydrolysis reaction, and one is the esterification reaction. These two reactions are opposite to each other. Similarly, neutralization reactions means except the this one, you take weak acid or weak base with respect to any strong acid, strong base, you will get a sort of corresponding acid and base and plus water. So this type of neutralization reaction is the example of reversible reaction. Only one exception I discussed, that is a reaction of a strong acid and a strong base. This is the only irreversible reaction. Rest of the reaction is under neutralization reaction with acid and base will be your reversible reaction, in which one acid should be weak or one base should be weak. This is the minimum condition for this reaction.